So what is C? C is a high-level language founded in 1972 at AT&T's Bell Labs. It was founded by Mr. Dennis Ritchie. C became very popular because of its large feature list and speed. Most of the operating systems, embedded programs that are used for microprocessors and games are built using C language. Many softwares which are built using C languages. Even today, many consider C language to be their first language to learn coding because of its simplicity. So when we write a C program, that program is basically used by compiler. It compiles that code to convert it into machine language code. Machine language code is the code which computers can understand. They cannot understand C program code directly. However, writing C programs is easier for us. So that is why instead of writing directly code in machine level language, we can write into C programs, which is a high level language, which is closer to English as compared to machine level language code, which is usually ones and zeros. So it becomes easier for us to write C program and then use compiler, which is again a system program which takes this C program, compiles it into machine level language for us. In this lecture, we are going to check a code block for C program. Every C program has this hash include in the angular brackets header files. So what these header files are? All header files contain predefined functions which we can directly use. We can also call them as dependency files, which can be used by your actual C program. We can include one or more header files. All C programs start with a fixed function name called as main. This is our main function. Every function in C returns a value. In this case, I am returning a value as int. We are going to check this in detail in next lectures. So the starting curly braces and ending curly braces indicates the point from where my main function starts and where it ends. So all the lines which are between this parentheses are my block of main function. Now let us check this in more detail. So these are my include header files. I can have multiple include statements. Then my main function starts from here. Now inside of my main code block, what I can have is declaration statements, decision control statements, loops, call to other functions, special keywords, and my return value. All these points we are going to check one by one in the next lectures. Before that, just want to make a point that how exactly a program is executed. Now, when we say execution, it doesn't mean actual execution, but when we talk about the compiler compiles your code line by line, and when it gets converted into machine code, that machine code is also executed line by line. So when I say a line, it's basically an instruction that we are providing to the computer. So computer executes your code block instruction by instruction. That is why it is necessary to understand how exactly we can instruct the computer in stepwise manner so that we can achieve our desired output. In this lecture, we are going to talk about format specifiers and basic functions that we require in order to take input from the user or to display our output to the user. So those commonly used functions are printf and scanf. Because we'll be requiring these functions quite often, so I'm covering this in the initial lecture only. So there are many format specifiers in C language. However, we are going to use %C, %D and %F for now, and rest of the format specifier will be checking in the next lecture. So %C will be used for character, %D will be used for integer, and %F will be float. So all these three data types we are going to check in the next lecture. Format for printf and scanf statement is like this. So let me explain how printf statement will be utilized. Printf, then starting double quote indicates starting of my string. So what I am writing over here is a number, %D, comma, a character, %C, comma, a float value, %F. And then I end my first parameter with another double quote. This whole part is my first parameter of the printf statement. Then I'm writing comma to add another parameter. So my next parameter is marks. Then again a comma, this is my next variable, and again after a comma another variable. So how exactly this printf statement will get executed? So at the time of compilation, my %D will be replaced by marks. this whole variable will be replaced by %c, and similarly my final variable value of pi will be used to replace %f. So hence, once this is compiled and at the time of execution, my output for this printf statement will be a number 10 comma a character p comma a float value 3.142 if these variables were having these values. Now next statement is scanf statement. So printf statement is used for displaying values. So this is used for displaying output, and scanf is used for taking values from user. So what scanf does is it tells compiler to take these three values, and I'm also mentioning what type of value to take from user and where to store those values. So when I say %d, I'm going to accept integer value, %c will be my character value, %f will be a float value, and all these three values will be stored one by one into these respective variables. My first integer variable will be stored at marks. My second parameter is character variable, which will be stored into this variable, first letter of your name, and %f, which is a float variable, will be stored inside of value of pi. In this lecture, we are going to check character sets and constants available in C language. The character set in C has all alphabets starting from capital A to Z, small a to small z, all digits from 0 to 9. We call them as decimal numbers, special symbols which are visible on your keyboard, and additional ASCII characters that we'll check in coming lectures. In C language, constants are of two types: primary constants and secondary constants. So what are primary constants? Those are basically three types. So primary constants in C are integer, real, and character. This we have seen in previous lecture. Integer are basically whole numbers. So these are a few examples: 786, plus 501, 0, -09. These are few integer constants. Similarly, we have real constants which have decimal point into it. So 3.142 is a real constant, -21.444, 55.00, these are also real constant. Then we have character constants. So small a, capital A, all special symbols. In fact, digit 9 as a character can be a character constant. Then we have secondary constants: arrays, pointer, structure, union, enum. These are secondary constants. We are going to check all these as our study progresses. In this lecture, we are going to check basic data types in C. So we are going to start with int, float, and char. In the earlier lecture, we have seen character sets which is available to us in C. So integer, real, and character are basic C constants. How we can utilize those in C is using data types. So int is your integer which can be utilized to store whole numbers, real values, or the values which contains decimal point. So these are few examples for data type. Float, these are few examples for character data type. So A, X are characters. Space is also a character. All digits can also be displayed as a character, and all the special symbols too. Apart from these three basic data types, there are more data types available in C, but that we will check in coming lectures. In this lecture, we are going to check what variables are. In C language, variables are used to store values which user has entered, or we calculate few values and we store our results into those variables to display output to the user. So there are few guidelines or rules in C to declare your variables. First point is, ideally your variable name should indicate what value it stores. Like, suppose I want to store a roll number, I should ideally declare the variable like this: roll_number. Because just writing R or A, B, C doesn't make any sense. Tell the programmer what exactly this value the user is storing. However, while developing programming logic, we might be using these variables in the shortest form like X, A, B, just because of the simplicity. But ideally, you should be writing variables in a better way so that you can understand what value it stores. Second point is, ideally, we should assign some value at the time of declaration. Otherwise, it will hold some random value and it can create some logical errors. Logical error is basically something that your program does not contain any syntactical error. It will execute, but it won't give you the desired output. So logical error makes your life very difficult because you have to debug and what exactly the computer is doing because it is giving you a wrong output. Variables should not contain any special character, but it can contain an underscore. Variables must start with an alphabet or underscore, and variable must not be an keyword. As we have seen in the earlier lecture, int, float, char are used as data types in C. So obviously you cannot have a variable name as int, float or char. So these are all special keywords which cannot be used as a variable name. So these are valid variable names, like I'm saying roll number, pi value, O, underscore super cool. These are valid variables, but these are few invalid variables. So roll dash number, why this is invalid? Because it has a dash and we cannot use special symbols apart from underscore. We cannot use constant as a variable name, and also a variable name must start either with alphabet or underscore. Here it is starting with a constant. Character 0. Why? Again, because it's a number, it's a integer constant, it is not an alphabet. That is why we cannot use 0 as a variable name. Also, we cannot use keywords, like if is a special keyword in C used for decision control structure, which we are going to use in coming lectures. That is why in specif is also invalid. Now we'll check how we can declare a variable in C. To declare a variable, we must write data type first. In this case, so far we have seen int, float and char are data types, so you can use based on our choice which data type you want to use, and then your variable name. You can also initialize a variable, which is a good practice of programming, using equal to operator. So here are a few examples. I am writing my statement as int space x semicolon. Semicolon is a character which is used in C to tell compiler that my instruction ends over here. So when I say int x statement completes over here, I can alternately write multiple instruction on the same line like this. Okay, but to have good readability, we write one instruction below the other. So when we declare a variable, what happens, assuming this to be your computer memory, when we declare a variable int x, compiler allocates memory to this variable. It names it as x, and this is address location of my x variable. When we do not initialize a variable, it will hold some random value. However, in case of y, what has happened? We are initializing y to 10. So when compiler allocates memory to this variable y, it is also overwriting value with my initializer, which is 10. So in case of x, this random value which was already there, we refer to it as a garbage value. In this lecture, we are going to check operators in C. C language has wide variety of operators. So these are all different types of operators which are available in C. However, for our current scope, we are just going to check assignment operators, which is equal to, plus equal to, minus equal to. There are few more assignment operators, but we'll check those in next lectures. So when I write instruction as a equal to 10, so a will hold value 10. In this instruction, value of x will be overwritten by value of y. The next example is I'm writing x is equal to x plus y. So suppose my y is, let's say, 2 and x is, let's say, 10. So my x will become 12. So this addition will get stored into x. So there's an alternate way in C. Instead of writing x is equal to x plus y, we can use plus equal to operator. So it works in the same way. What it says is increment value of x by y. So I'm saying increment value of x, which is 10, by 2. So my x becomes 12. Similarly, instead of writing a equal to a minus y, I can write a minus equal to y. In other words, I am decrementing value of a, which is 10, with value of y. So 10 minus 2, 8 will become my new value of a. Apart from assignment operators, we also have arithmetic operators. So plus minus, instead of multiplication like X, we use star operator in C as a multiplication operator. Then division, and then modular division as well. So there's a difference between division and this percent sign. So in case of normal division, suppose I am going to divide 7 with 2. Okay. So in this case, this will be result of my division, and this will be division of my percent sign. So when I write instruction like 7 divided by 2, my output will be 3. And if I write 7 modular division 2, my output will be 1. Similarly, if I write 3 modular division 3, it will be 0. And 3 divided by 3 will be equal to 1. I'm taking another example. Let's say 17 divided by 15. So output of this will be 1. And 17 modular division 15. In this case, my output will be 2. In this module, we are going to talk about escape sequences. What are those? You might have noticed that inside of printf statement, we have this double quote. Okay, let us consider a case where suppose you want to print a double quote. Now, the rule of printf statement is that there has to be equal number of double quote. This printf statement has starting quote and ending quote. Now, what about this? So this will confuse the compiler, and the compiler will give an error about unterminated string. So in that case, to tell compiler explicitly that this double quote is for printing purposes, we add a slash. So the compiler on the output device replaces slash double quote with double quote. Okay. Similarly, if you want to print a single slash, we'll have to provide double slash. Why? Because slash itself is a escape sequence. Similarly, these are all escape sequences provided in C language. The ones which marked in bold are we are going to check in the current scope. So slash n basically new line character. Tab is a tab sequence. Like when we enter a tab on the keyboard, so that is emulated on the screen. Double backslash is for printing a single slash. When we have to print single quote, we write slash quote. Similarly, as we discussed, slash double quote will print a double quote. So rest of the escape sequences we'll check in upcoming lectures. This is a basic program wherein we are going to print URL for kodegod.com. Okay, so actual URL is http://www.kodegod.com/learn programming. So what compiler will do, because we want to print double slash, we'll have to add double slash as escape sequence for printing single slash. Similarly, for the second slash, we'll have to provide double slash. So to print 2 slashes, we are required to provide 4 slashes. Okay, similarly, these 2 slashes will be replaced by a single slash. Okay, so my final result will be http://www.kodegod.com/learn programming. In this lecture, we are going to learn about decision control structure. One of the most important topic, what are decisions? When we have a question and it has 2 answers, like if I ask you, would you like to have a tea? Your answer could be yes and no. Now, depending on your choice, I can offer you either tea or maybe I can ask you something else. So usually when we talk about condition, is basically a question. So assuming these to be few statements in the program, at some point of time, I might have a decision to make. So suppose I'm saying, do you have a question? So now this can have 2 outputs. One could be yes and no. So if my choice is yes, I will execute these set of instructions. If my answer is no, I will execute these set of instructions. In case of no, all these statements will be skipped. Let us take another example. Suppose I have initialized 2 variables a and b, 10 and 20, and I'm going to check whether a is greater than b. Now this is my condition. Okay, now this condition can be either true or false. If the condition is false, we can print b is the larger number, and if the condition is true, we can print a is a larger number. In this lecture, we are going to check syntax for decision control structure. As we have seen, all decision control structures will have a condition associated with it. So every condition will hold a result which can be evaluated to either true or false. So these are few valid conditions: a greater than b, a greater than 10, 0 and 1. Now how these are valid conditions? All the conditions are evaluated to a certain value. If value is 0, the result is false, and if the condition is evaluated to any non-zero number, it will be treated as a true. In this case, 1 is true and 0 is false. Similarly, minus 100, little constant a, all these values are true. Now let us check the syntax. So this is general if statement. Format 1 as an example is if inside of parenthesis I am writing condition. If the condition is true, all these instructions will be executed. This whole part is my if block. If my condition is false, this whole block will be skipped. It will not get executed at all. Now let's talk about format 2. If my if block has a single instruction, I can exclude writing curly braces. So we can just simply write my condition and the instruction. So this instruction will only get executed if the condition is true. Now we will check if else statement. So similarly, like if, whole format for if it's same, but what we will do here is only if my condition is true, some statement will get executed. However, in case of condition is false, we were not writing anything. So if we have those kind of cases, we can write else block. Okay, so if my condition is true, this whole thing will executed, else these statements will get executed. Similarly, if we just have single statement for if else, so there's no need of writing curly braces over here. Okay, you can just simply write if condition, your instruction 1, else instruction 2. We can also write if else as a nested conditions like this. I'm writing if block, then this is my else block. So after this else, I'm adding another if statement. Okay, and then this is the block for that if. And if this condition is false, I'm going to write else. So this block will always get executed if my first condition and second condition both are false. Okay, so how this program will execute? Let's check. If this condition is true, this block will get executed. If it is false, it will check the next statement. If this condition is true, this block will get executed. If this condition is false, it will execute this block for else. Again, you can exclude this else based on your programming logic. Else part is completely optional. The same block can be written like this if you have just single instruction for each of the block. Okay, so if this condition is true, this will get executed. Else if this condition is true, this will get executed. Else instruction 3 will get executed. In this lecture, we are going to learn about logical operators. In C, there are 3 logical operators. First one is AND operator, which is denoted by double ampersand. Then we have OR operator, which is denoted by 2 vertical strokes. And then we have NOT operator, which is denoted by exclamation mark. So what is AND operator? In AND operator, if both the expressions or both the conditions are true, then that complete expression, which includes 2 conditions, will be true. Else it will be considered as false. In case of OR operator, if any of the 2 conditions are true, then whole condition inside your if or else if will become true. And in case of NOT, it will just negate the result. So if your original condition is true and if you have applied a NOT operator, it will become false. If your condition results are false and you have applied NOT operator, that will become true. So this is a small table for better understanding. So when we apply AND to my first condition and my second condition, okay, so if my both the conditions are true, so my result will be true. Else in all the cases, if you check over here, it is false. So it doesn't matter whether one of them is true. Okay, both the conditions or all the condition has to be true. Only then my final result will be considered as true. So for even simpler understanding, when you apply AND operator, just simply read it as all. So when all conditions are true, only then your final condition will be true. Okay, so suppose this is your first condition, this is second condition, and this is third condition. If all of these conditions are true, only then this if block will get executed. If any of the condition is false, else block will get executed. Now in case of OR operator, OR means any. So if any of the condition is true, okay, let us check this table. If condition 1 and 2 are true, or if any one of the condition is true, here condition 1 is true, in the second row, in the third row condition true is true, in that case both the results are true. If both the conditions are false, only in that case OR will hold result as false, else everything will be true. Okay, so OR is equal to any. So in case of if statement, if any of this condition is true, this will get executed. So how to read it? If true or true or true. Okay, so if any of these three condition is true, this part will get executed, else this will get executed. So when all are false, in that case else block will get executed. Now in case of not, it is very simple. It will just negate result of my existing calculation. Okay, so suppose I am writing true, not. Okay, so technically this is equal to false. Okay, similarly if my result is going to be, let's say, false, I'm writing negation operator, so this is equal to true. In this lecture we're going to learn about conditional operators. So syntax for conditional operator is, inside of parenthesis you can write your expression or condition, and after parenthesis a question mark is compulsory, and if the condition is true, this will get executed, and if condition is false, this will get executed. So let us take an example. If a is greater than 0 question mark, then this will be printed if a is really greater than 0, else we are saying b is greater than 0. Okay, conditional operators are used as shorthand method for writing your decision control structure. However, they make it little difficult to read. They can also be used as assigning values to a variable. If this is my condition, x equal to 1, this value will be stored into y if it is true, else 0 will be stored into y if the condition is false. Instead of using assignment, we can also directly write those values into printf statement like this. Okay, so if x is equal to 1, 2 will get printed, else 0 will get printed if the condition is false. Here is the program for finding out largest values from two numbers. So I'm asking user to enter two numbers a and b. So if a is greater than b question mark, I'm just directly going to print largest number is a, else largest number is b. For example, let's say user has entered 10 and 20 as a and b. So 10 greater than 20, which is false. So the program will print largest value is b. In this lecture, we are going to learn about loop control structures. Why do we need loops? In programming, wherever we require repetitions, we will require loops. Now, consider a case wherein you are required to print 10 numbers starting from 1 to 10. Easiest way that we write printf statements like this. But this is not an ideal solution. It is okay to have this logic for printing 10 numbers. What if we are required to print 10,000 numbers or 1,000 numbers? In that case, it's a very tedious job that the developer will have. Also, you can imagine having 10 instructions requiring 20 repetitions. In this case, we are just required to print a single number. But now, suppose there's a stepwise operations which has around 10 to 15 instructions in a single iteration, and we are going to require, let's say, suppose 200 iterations like that. So for 10 instructions, we will need 200 instructions. So in that way, the program will have to write around 2000 statements to complete that logic. However, if these 10 statements are repetitive, so if we use loop control structures, we just need to perform these 200 iterations over these 10 statements or 10 instructions. So that is why when we have this repetition, the loop control structures is an ideal solution. In C language, there are three types of loop structures available. First is while loop, do while loop, and for loop. In this lecture, we are going to look into while and do while loop. So this is the syntax for while loop. So while is the standard keyword used in C to tell compiler that I'll be using while as a loop control structure in the program. Inside of parenthesis, I will have my condition, and if this condition is true, these statements will get executed. In other words, till the time this condition is true, these statements will be executed. Once the condition becomes false, these statements will not be executed and the controller will directly jump to the next set of instructions. Do while loop is similar to while, only thing is that condition is checked at the bottom. So this is my code block for do while loop. Do is another keyword which tells compiler that my loop is starting from this point. However, because condition is checked at the bottom, this whole block is executed once. After first execution, this condition will be checked, and if this condition is true, again these statements will be executed. If it is false, the compiler will move on to the next line. Why do we need two different loops, do while and while loop? So I'm going to explain what are basic differences between these two. First is the condition in while loop is checked at the top, and in case of do while, condition is checked at the bottom of the code block. In case of while loop, code block will never get executed if condition is false. However, in case of do while loop, even if my condition will be false, the code will get executed at least once. Before we start programs on while and do while, let us look into these two operators, increment and decrement. So increment operator is denoted by plus plus sign and decrement operator is denoted by minus minus sign. So plus plus, how to use this operator? We just need to use our variable name which we want to increment and then use plus plus sign or variable name and minus minus sign. I plus plus is same as I is equal to I plus 1 and I minus minus is same as I equal to I minus 1. There are two ways in which we can use these operators. First is pre-increment and second is post-increment. In pre-increment we write plus plus I, in post-increment we write I plus plus. So what is difference between these two? Both of these statements will be incrementing value of I by 1, but if we write this statement I plus plus in printf statement, so while printing value of an integer over here, it will take current value of I and then increment value of I. So if I was equal to 10, so at the end of the program value of I will be 11 and printf will print 10. Okay, but in case of plus plus I, the incremented value will get printed, that is it will print 11 and also I will become 11. So you either write I plus plus or plus plus I, increment will always happen, but when you're going to consume I plus plus or plus plus y either in printf statements or in evaluations, that time either this will be used or this will be used. Let us take another example. I'm using two variables x is equal to 10 and y is equal to 20. If I write x is equal to y plus plus, so it will obviously going to increase value of y by 1. So your y will become 21, but before that current value of y will be stored in x. So your x will be 20. Let us take another example. This time we will be using pre-increment. So I'm using two variables I is equal to 10 and b is equal to 20. So at this time b will become 21, but a will store incremented value of b, that will be 21. So I hope you understood what is difference between pre and post. Similarly in decrement we have pre-decrement and post-decrement. Let us take an example for it. Suppose I am using I equal to 20. So while executing this, current value of I will be printed, that is 20, and I will be decremented to 19. Now again, assuming I equal to 20, while executing this statement, decremented value of I will be printed, that is 19, and I will become 19. Another example, I am using two variables x equal to 10, y equal to 20. When I write x is equal to y minus minus, so current value of y will be stored into x, so x will be 20 and then y will become 19. Similarly, if a is equal to 10 and b is equal to 20, decremented value of b will be stored in a, so a will become 19 and b will be 19. Now we are going to learn about for loops, which are very commonly used loop control structures. So this is the general syntax for loop. So for is my special keyword which denotes starting point of the for loop. Immediately next to for loop we have starting parenthesis, and after that we have initialization. So the variable that we will be using for maintaining count of each iteration will be initialized over here. So initialization happens only once, that is in the beginning of the for loop. Once the initialization is done, the compiler will check for the condition specified after the semicolon. So this is second statement that we will be adding inside your for loop. So if the condition is true, compiler will go inside the for loop and it will perform all the statements which are inside your for loop. Once the execution gets completed for this block, then the compiler will perform either increment or decrement, whichever is specified in the instructions. So once increment and decrement is done, compiler will go back at the top and recheck the condition. Again, if the condition is true, the same steps will be performed. Once these statements are executed, compiler will then again increment or decrement those values. It will again check back the condition, again perform these statements, and so on. So once the increment and decrement is done, if my condition is true, these steps will be performed. If my condition becomes false, these statements will not be performed and compiler will come out of the for loop. Let us check an example now. Suppose we want to print numbers 1 to 10. I'm initializing one variable as int I. Then my for loop is starting over here. This is my initialization statement. I am initializing I to 1. Then my condition is I less than equal to 10, which is a true condition. So compiler will go inside and print value of I. Once this is done, as the block has ended over here, it will increment value of I. So I will become 2. Then compiler will check for this condition. As 2 is less than 10, it will go again inside of for loop because the condition is true. And after that, the cycle will continue for increment and then condition. If the condition is true, for loop will get executed, else it will come out of the loop. So once your I is incremented to let's say 10, the condition will be checked as 10 less than or equal to 10, which is a true condition. So compiler will go again inside of for loop. It will print 10. Now once the value is printed, value of I will be incremented to 11. And then once the compiler checks for the condition, 11 less than or equal to 10, which is a false condition. So the compiler will not go inside for loop and it will terminate the program. Let us take another example where we are going to print numbers 10 to 1. So again, I am declaring my variable I, and inside of for loop, I am initializing I to 10. Then the compiler will check for the condition whether 10 is greater than or equal to 1, which is a true condition. So it will go inside of the loop and print I. Once the block of for loop is executed, it will decrement value of I to 9. So again, it will check for the condition. The 9 is greater than or equal to 1, which is a true condition. Again, it will go inside and print the value, and this decrement and then checking out the condition will continue till the condition is false. So let's say when your I becomes 1, the condition will be checked as 1 greater than or equal to 1, which is true condition. So all the statements which are here inside of your for loop will get executed. It will print value of I, and then value of I will be decremented to 0. So the compiler will check condition as 0 greater than or equal to 1, which is a false condition. So it will skip this body of your for loop and the for loop will get terminated. So in the next lecture, we are going to look at few examples on for loop. Now we are going to learn about pattern programming. Before that, let us look how console screen looks like. Console screen is a 2x2 matrix of rows and columns. So these are all rows and these are all columns. Each combination of row and column is a display unit. So at the first display unit, we have display W, and in the next display unit, we have another W, and so on. In the next row, we have few blank spaces and then another row with these characters. So each display unit is capable of displaying one character constant. Now how the screen structure is accessed, it is not always necessary to specify a display unit in terms of rows and columns, but if you want to access a particular location, like in this case 3 and 3, in that case you'd ideally require that location of that particular display unit. Console screen has something called as cursor. So when your screen is blank, the cursor will be at this location, which is the starting location. So cursor will be blinking over here. So as soon as something is written over here, like in this case, when W is written, then the cursor will move on to the next screen and then it will print something else. So like in this example, once all of these rows are printed, then cursor will be at this location. Depending on different screen resolution and sizes, total number of available rows and columns can vary. So on some screens, it could be 80 rows and columns, or maybe 80 by 90, 100 or 100 by 50 and so on. So this is something that depends on hardware and software configuration. In the next video, we are going to learn about actual pattern programming, which are common shapes to be printed on your output screen like this and so on. These are very common problems, but are very important while you develop your programming logic. This will make your understanding of for loops and screen formatting very clear. In this lecture, we are going to learn about Goto keyword. So here's the syntax how to use Goto keyword. Suppose we have some instructions in your program. Then we have Goto, which is a keyword which instructs compiler to take program control to a particular label. So in this case, wherever we define a label, all the instructions coming after your label will be executed. So this whole code block will be skipped. Let us take an example. Suppose you have a variable as int. Here you are asking user to enter an integer and it will be stored into address location of age. Then we are adding a condition and checking whether age is less than 0. If this condition is true, we are instructing compiler to go to invalidator, which is my label over here. So this statement will not get executed. However, the controller will be redirected to this instruction and then this printf statement will be executed. Let us discuss more points related to Goto keywords. First point is you can have any number of Goto statements and any number of labels in your program, and you can have multiple Goto statements pointing to single label as well. Second point is a valid use case scenario of a Goto keyword could be in a case wherein you have multiple for loops like this, and then based on some condition you can use your label. So if this condition is true, then the compiler will be redirected to this line directly and these statements will be executed. So in this case, we are breaking normal program execution with an exclusive condition and using our Goto keyword. The final and most important point is avoid using Goto keyword, as it makes debugging and understanding of your program little difficult. As if you have multiple Goto keywords, your program can have different flows. And if you have multiple Goto keywords, that will lead to many logical errors and that can make your program unreliable. Programmers usually find tempting to use Goto keywords, but with the experience you'll understand that use of Goto keyword should be very limited. And there are always other ways in which you can develop similar logic instead of using Goto keyword. In this lecture, we are going to learn about two important keywords used in C language. One is continue and other one is break. We are learning about this before switch case because break is a keyword that we will be required in switch case. So let us take an example for continue keyword. Continue keyword must be used within a loop. So I'm taking a while loop over here. Until this while condition is true, we are sure that instruction 1 and 2 will always be executed. I'm adding a condition here. So if this condition is true, again instruction 3 will be executed. Now because I have added a continue keyword over here, as soon as controller reaches to this statement, the controller will go back to while loop, starting of the while loop again. So in this case, instruction 4 will be skipped. Again in the next iteration, instruction 1 and 2 will be executed. If the condition is false, this whole block will be skipped and instruction 5 will be executed. So this whole process will continue until a while condition is true. So continue keyword can be used wherever you want to skip few instruction based on some condition, because you cannot have continue directly, otherwise there is no point of using it inside a while loop. So this condition is not compulsory, but ideally there would be examples where you will need to skip few instructions based on some condition. In such cases, you can use continue keyword along with some condition specified in if. Now let us check break keyword. Again, the break keyword can be used either in switch or a loop. I'm writing this example with while loop. So until my while condition is true, these two instructions will be executed. I'm adding another condition over here. So if this condition is true, instruction 3 will be executed. So as soon as controller reaches to my break keyword, it will break my existing for loop. It will go to the immediate instruction which is after your while loop, and similarly subsequent instructions will get executed. So break is a very useful keyword which you can use to break existing block of code. In this case, my block was of while loop. Similarly, you can have it inside switch loop as well. So switch case is a topic that we are going to check in the next video. But before that, let us check few examples on break and continue keywords in the next video. In this lecture, we are going to learn about case control structure. So let us start with learning the syntax for case control structure. Switch is a keyword that instructs compiler that our case control structure is beginning from this point. So inside of parenthesis, we have a variable for which the cases will be planned. So this is the whole switch block. This is starting of your switch case, and this ending parenthesis denotes ending of your switch case. So a switch block can have multiple cases, like I have case 1 over here, case 2 over here, and so on. We also have a default case. Whenever a case is not satisfied, that default case is executed. So typically, when a particular case is evaluated to be true, that case block is executed. If case does not match anywhere with the variable, then the default case is executed. So let us take a valid example. Assuming a value n which is provided by user, if n is equal to 1, then this case will be executed. Okay, so this case will be true and all the instructions which are inside of this case block will be executed. Alternatively, if n was equal to 2, then this block will be executed. If we assume that n was equal to 3, then these two cases will be ignored and this part will be executed. Let us take another example. I'm using a character variable over here as gender. Suppose user has entered M. In that case, this block will be executed. In case of F, this block will be executed, else the default case will be executed. Notice that the value expression I'm writing in single quote over here. Case control structure is preferred instead of nested if when you have multiple values to be evaluated. Only problem with switch case that we cannot write any conditions over here or here. In the next lecture, we will look into more details of a case control structure. We'll also discuss break keyword, which we have seen in the previous lecture, and why using of break is necessary in case control structure. In this lecture, we are going to learn case control structure in more detail. So we need to discuss around 8 different points related to case control structure. We are going to use this as example for discussing these 8 points. First point is use of default keyword is optional. When we use switch case for a variable, default is optional. So you can use your cases directly instead of writing default. However, to have proper validations in place, you should ideally write default case. Like for example, in this case, suppose user's input does not matches any of the given cases, we can print invalid entry so that user will come to know that he has entered a wrong value. So that was our first point. Next point is sequence of cases is not necessary even for default case. So as we have seen, default is appearing at the top, so that is okay. Also, we have case 1 over here and case 3 over here. That is also okay. We can also write case 3 at the top, default at the bottom or in the middle. So sequence does not matter. Next point is cases can be clubbed together. So we can have something like this: case 2 colon, case 3 colon, case 4 colon, and we can have some common instructions for these 3 cases. So whenever there is a match for any of these 3 cases, these statements will be executed. Next point is there should not be any repetitions. So obviously when you're writing a case over here, you cannot repeat it again. You can also write mathematical equation using constants only. So case 2 plus 1 is okay, but as it is going to evaluate it to 3, which we have already written over here, so compiler will give an error. Alternatively, if the statement was like 2 plus 6, which will be evaluated to case 8, so that wouldn't have given us the error. So that was our 5th point, that expressions can be used but without variables. So writing something like this is invalid. So suppose a plus b, so these are variables, that is invalid. Next point is that we cannot use conditions. So writing case of this form is not possible. So ideally in these type of conditions you should use if else and not case control structures. The next point is very important, that use of break is necessary but not compulsory. So to understand this example, let us assume that we have not written break over here for case 1, and assuming that a is equal to 1, so in this switch case all the instructions which are inside of case 1 will be executed, but as we have not written a break keyword over here, compiler will fall through and execute the next case as well. Once it reaches this breakpoint, it will come out of your switch block. So that is why ideally we write break keyword after each case block. The final point is all additional condition used inside of switch block will not give any error, but those will not be executed either. So inside of your switch block you can write if else, but those block will not be executed at all. Compiler will simply ignore those statements. So this is not really important, but this is something can be asked in your technical interviews or some other quizzes. So that is all for case control structures. In the next lecture we will look into some programs based on case control structures, which will make your understanding more clearer. In this lecture, we are going to learn about functions, which is very important building block of any programming language. Generally, a function is a block of code that performs a specific task, which makes it reusable and can be used multiple times. So when you have a certain number of instructions which are needed to be used based on certain conditions, or we require to use it for some number of repetitions, then we can use functions. To explain use of functions, we can write a function for adding two numbers, and whenever in our program or module we want to add two numbers, we can call that function directly. Now obviously addition is something that can be achieved easily by using addition operator. So using functions for such small operation doesn't make any sense. But consider a case wherein you're required to perform some complex operations on those two numbers. For example, calculating mean and standard deviation in the same function for a given set of data points. So for this example, you can write a function and use it whenever you want to calculate standard deviation. Another advantage of function is that it makes your program easier to understand, because you have broken down your programs into multiple set of codes. There are two types of functions. One is standard library functions that we have already used, like printf, scanf and getch. And the other type is user-defined functions, which user defines in their code. So let us check how user-defined functions can be used. Consider this block of code. This block is your function definition, that is where you define your function. So usual syntax is a written data type, then your function name and parenthesis. Starting curly braces and ending curly braces denotes start and end of your function. Inside of curly braces you have instruction to be executed. Then in continuation you have your main function. Inside of main function you can write your regular instructions. Then you can call your defined function like this. For calling a function you just need to write function name and parenthesis. After that you just need to add semicolon. In the next lecture we will take an example of user-defined function. We will also check how parameters can be passed to a function. Let us check again the syntax for defining a function, but this time we are adding parameters to it as well. So this is your function name and this is your return type. So return type is basically any data type. So your function will perform some operation over here and the same data type will be returned by this function. So a data type can be void, int, float, but when you define integer as a return data type for your function, then your function should return integer type of value only. Now to add parameters to your functions, you just need to specify data type and variable. You can add any number of parameters to your function. For example, I can specify, let's say, float variable a, then I can take any other data type, let's say int b. So you can have any data type and any number of variables for your functions. Now let us take few examples to understand this concept better. In example 1, I have defined function as add, to which I am passing two integers and it will return me an integer. This is how we should define a function. Now inside of this function I am performing my operations. I'm adding two passed values a and b and storing its addition into new variable c. So in this statement I am declaring a variable c and I'm initializing addition of a and b into c, and in the next next statement, I'm returning C. Now notice that C is a type of integer which we have declared over here. So this value will be returned by this function whenever it is called. Let us take one more example. In example 2, I'm defining one more function to which I'm passing a single variable as float, and it will return me float type of variable. Notice that I'm not declaring any additional variable in this function, but we are returning calculated value in line to the return statement. So return is the keyword which tells compiler that this value will be returned by my function. So what is happening over here? 3.142 is a float variable, radius is a float variable, again the radius is float variable. So multiplying these three will give me a float variable only, which will be written by our function. Let us take one more note over here. When a function is called, we can either pass constants to it or we can pass variables to it. So once the function performs the operations, the value is assigned depending on its data type. So in this case, I'm calling add function, and a result returned by add function will be stored into X, which is integer. Now this data type of your variable X should be same as return type of your function. If there is a mismatch, then compiler will give an error. In the next lecture, we will check few programs on functions that will make your understanding for the functions more clear. Before we continue our study on functions, let us learn a little bit about pointers. Pointers, which is always considered difficult to understand, however, it is one of the most easiest topic in C programming. Let us consider this as memory location, and we have assigned this memory location to variable age with initialized value as 23. So our standard statement would be something like this: int age is equal to 23. All memory locations have some address associated with it. That is how compiler accesses the variable. So this age is your variable name, 23 is the value stored at address of age, and this is address. So let us see how these can be denoted in C language. We can simply use age to fetch value stored in that variable. In C, the star is used as indirection operator. To easily understand use of pointers, you can replace it with value at and then read subsequent part. So this whole thing can be read as value at address of age. Okay, so this will signify 23. Let us see how we derived at that value. We are saying value at address of age. So address of age is this, and value stored at this address is 23. So star ampersand age will give you 23. When we just simply say ampersand age, it is nothing but address of age. So very important takeaway from this lesson is of star operator and how it can be used to derive original value from address of another variable. So put it very simply, pointers are variables which store address location of another variable, and hence the pointers can be used to derive value stored at that address location. In the next lecture, we will check how pointer variables are declared and used. In this lecture, we'll check how pointers can be used. I'm taking one example where I'm declaring an integer variable a equal to 10. After that, I'm declaring my pointer. So what pointer is doing over here, I'm using indirection operator at star and initializing an integer pointer named as ptr, and I'm initializing it to address of location a, which is variable that I have declared over here. Address of variable a, and after that I'm printing three integers. First I'm writing star @a. In the previous lecture we have seen that this star can be replaced with value at. So if we just simply read it, what printf statement will be printing over here is value at address of a, that will be 10. Similarly, in the next line we can write star and inside of parenthesis address of a. So both are same. It is just to make it better understandable, I'm writing it like this. So this will also print 10. Alternatively, here we are writing star ptr. So star again is value at, and ptr because it stores address of a, so this is something like this again. Okay, so this will also give me same result, 10. Okay, so this will make your understanding of pointers clearer. 10 is the value which is stored at a. However, using its pointer, I'm still able to print that value. This is very basic concept of pointers. If you have understand this, there is nothing much complicated into pointers. In the next lecture, we will continue our study on learning about functions and how different types of parameters can be passed to it. In this lecture, we are going to learn about calling a function by passing value or reference. We'll first take call by value. In this example, I am defining a function as add, to which I am passing two integers and it will return me an integer. So I'm declaring another variable int c and storing addition of a and b into it, and then I'm returning c. So inside of my main function, I'm initializing a to 10 and b to 20. I'm also declaring one more variable as c, and then in c I'm storing value returned by my function add. So in this example, I'm passing variable a and b as values. So 10 and 20 will be passed to the function add, and those values will be added and stored into c, and this c will be returned. Let us take this example. I am defining a function having two integer pointer variable as parameters. Then I'm writing star a, star b, adding them and storing it into c. So what star a is doing over here and what star b is doing over here, that I will explain you in a bit, and then I'm returning c. So while calling this function from main, I'm using two variables as integer initialized to 10 and 20, and then c is a variable where we'll be storing our output. So I'm calling my function add and I'm passing references of these variables. I'm passing address. So whatever the address location would be, like 7001 or 7002, that address will be passed over here. So what technically is happening over here is star a will be equal to address of a and star b equal to address of b. Okay, so in this statement we need to read it as star replace a with address of a, and we know that we need to read star as a value at operator. So value at address of a plus value at address of b. So we are adding 10 and 20 using pointer variables which are pointing to address location of these variables. It is important to note that this a is integer and this int star a is integer pointer. But then what is advantage of using call by reference? In the first program, we have declared in total 6 different variables, int a, b and int c in our user defined function, and then another set of a, b, c in main. However, in case of calling by reference, we have created 3 variables for which memory location will be required, and inside of our user defined function, we have just created pointers. Those are not variables actually. Now, because we already have a pointer variable, let us consider this second example so that you'll understand advantage of using pointers more clearly. Here I am defining a function to which 3 integer pointers are passed. Then I am simply writing star c equal to star a plus star b. So what is happening over here? Let me explain you this in a bit. So inside of main, I am declaring 3 variables a, b, c, and a I am initializing to 10 and b to 20, and then I am directly calling my function add and I am passing address location of a, b and c. So when the function is called, these 3 integer pointers will start pointing to this location. The addition will be stored at the address location of this c variable. Okay, so after executing this statement, if you print values of a, b and c, it will print 10, 20 and 30. Notice that in example 2, we were not required to return value of c. However, we are simply storing value in the original variable c by using reference of it using the pointers. In the next lecture, we will check what is scope of a variable and in which block of code variables are accessible. In this lecture, we are going to learn about scope of a variable. Let us take an example. In this example, I am declaring a variable outside of your main function. When we declare a variable outside of any scope, that variable is treated as a global variable. So this variable is accessible throughout your code. Now, inside of your main function, I am declaring a local variable, initializing it to 10. Then I am assigning 11 to global variable. So at this point, local variable is holding 10 and global variable is holding 11. In the next statement, I am simply displaying global variable. So compiler will display 11 on the output screen. In the next line, I am calling addition function to which I am passing address of local variable to pointer local underscore variable. So this pointer is pointing to address of local variable, and then simply I'm returning value at address of location variable. So what is happening in return statement? This is value at address of local variable, because this local variable is nothing but address of local variable. So if we just simply read it, value at address of local variable. So what is value at address of local variable? It is 10. So what we are performing over here is 10 plus global variable, which is 11. Notice that global variable is directly accessible over here. We have not declared it again inside of this user defined function, and this value 11 was assigned by our main function here. So the compiler will print 21 for this instruction. So here is the output. Let us take one more example. I am declaring a global variable a equal to 20. Then I am defining a user defined function sum, to which I am passing two integers, and it will return me an integer. Then inside of main, I am declaring these three local variables. Notice I have a equal to 10 over here, and we also have a equal to 20 as a global variable. So for this statement, when we print value of a, it will print 10 and not 20. Why? Because local variables are always given higher precedence over global variables. Then I'm calling function sum, passing parameter a and b, and the result we are going to store into C. So what values will be passed over here? 10 and 20. So 10 is local value of variable a. So from this point, compiler will go to this line. So value that this sum function has received are 10 and 20. So compiler will print 10 over here and b, which is 20, and it will return 10 plus 20. So C will become 30. So in the next line, we are simply printing value of C, which will be 30. So here's the complete output of this program. Important point that I wanted to make in this lesson is about formal variables, wherein local variables are given higher precedence than global variables. In the next lecture, we are going to write few programs on function, so that will make your understanding more better. In this lecture, we are going to learn about recursions. So what are recursions? Whenever we require repetition, we can call a user-defined function repetitively by calling the function inside of definition of the same function. So in this example, recursive underscore function is a user-defined function that I have declared, and inside of this function, maybe after executing few statements over here, I'm calling the same function again. So this function is calling itself recursively or repetitively. That is recursion. But all the recursive programs has to be called somewhere from another function. So in this case, I'm initiating my first call from the main function. So once program starts executing, once this line is executed, controller will go to this point and this function will keep on calling itself. So if a function is calling itself recursively or repetitively, then there has to be condition placed so that we can come out of that repetition. If you do not conditionally break that repetition or recursion, then the program will keep on executing infinitely. That is why it is very important to write certain condition so that you can break your recursion. In the next lecture, we will check few programs on functions and recursion. In this lecture, we are going to talk about very important topic, which is arrays. Arrays are nothing but collection of data. So in normal scenarios where we declare an integer, then that integer is capable of storing a single data value. Now suppose if we want to store multiple data values, in that case we will require some type of storage which can store those multiple data values. Arrays can alternatively also called as sequential collection of same data type. What that means is I can have multiple integer variables clubbed together which can be called as a collection of same data type. So in this example, I am using this variable x, which is an array of size 4. So this is collection of a data type which can store 4 data values. All array variables will have an index which are used for accessing and storing values into those array variables. So if you have arrays of size 4, then its index will start from 0, then 1, 2, and then 3. So all array indexes will always start with 0. So why do we need arrays? Let us take one hypothetical example where you are required to declare hundreds of variables. In that case, instead of declaring those variables like this, marks 1, comma marks 2, comma marks 3, you can alternatively use arrays like this. So I am declaring a variable marks with size of 3. So here marks will have these 3 variables as a collection called as arrays, and all these 3 individual variables can be accessed using their index. Again, just to revise, X is an array which is a collection of same data type. Here in this example, I'm using X as an array of size 4. So X0 is my first element and X3 is my last element. In the next lecture, we will check how we can declare, initialize and use arrays in a program. In this lecture, we are going to talk about declaring, initializing and accessing array elements. The topic name is single dimensional arrays. So normal arrays with a single index that we define are called as single dimensional arrays. In the next lecture, we are going to check what are multi-dimensional arrays as well. But for this lesson, let us keep our scope limited to single dimensional arrays. So let us first check how we can declare arrays. So syntax is like this. You need to specify your data type like int, float or char. Then you need to add your variable name. So all the standard rules which apply to declare a variable will also be applicable to declare array names. And then inside of square bracket, you need to specify array size. So here is one example. I am declaring an array of type integer, naming it as marks, and I am specifying array size as 7. So I am declaring collection of 7 integer variables, marks 0, 1, 2, 3 and so on till marks 6. So total 7 elements. Similarly, in the second example, I am declaring an array of type float, naming it as averages and setting array size as 10. So it will be an array of 10 float variables. So once declaration is done, let us see how we can initialize arrays. Here I am declaring an integer array as marks, initializing it with setting data size as 7, and to initialize an array after equal to sign, you can specify all the possible values inside of curly braces. So for integer array of 7, I have specified 7 integer variables over here. Alternatively, if you are going to specify explicit 7 values, then you can skip specifying array data size. So compiler will automatically initialize array marks with the data size of 7. Hence the compiler will allocate 7 memory locations to store these data values. So when these type of declarations are done, then your arrays are stored sequentially like this. So this 10, 20, 30 are data values and these are address locations. So if integer requires 4 bytes of data, then this address location plus 4 plus 4 plus 4 and so on will be total storage required for your declared arrays. Here is another example where I have declared a character array with data size as 2, naming it as options, and I'm initializing it with T and F, which is short form for true and false. Also notice that I have specified these values inside of single quote because those are character values. Now let us check how we can access array elements. Array elements can be accessed via their index value. So by specifying an index, you can access that particular array element from the collection. So in our previous examples where we have initialized array marks, so this is my index 0, 1, 2, 3, 4, 5 and 6. So marks 3 is representing value 40. So in this statement, compiler will print 40. Similarly, in this arithmetic statement, marks 0 is representing 10, marks 1 is representing 20 and marks 3 is representing 30. So 60, which is result of this addition, will be stored into total. You can also traverse array elements using another variable. Like to traverse all array elements, I'm using a variable I, initializing it to 0, and I'm writing a condition where I is less than 7. So this loop will be performed in the iterations 0, 1, 2 till 6. Because 6 is less than 7, that is the maximum possible value for which the condition will hold true. Once I is incremented to 7, 7 less than 7, which will be a false condition, so this for loop will terminate. So for these 7 iterations, what we are doing, we are adding marks into previous value of total and storing the result again into total. So in the next iterations, total gets updated. So in this for loop, what we are doing, we are traversing this whole array collection and adding these each element. So at the end of this program, total will have total of all these elements. So at the end of this for loop, total will have addition of all these data values. In the next lecture, we will check few programs on single dimensional arrays. In this video, we are going to learn about multidimensional arrays. Let us first see how declaration will be done for multidimensional arrays. It is similar to declaring single dimensional arrays. We first write the data type, then array name, and then size of the array. So because we are saying these are multidimensional arrays, when we have two different sizes, those are two-dimensional arrays. If we have three sizes, then those will be called as three-dimensional array, and so on. So technically, you can declare arrays with n number of dimensions. In this example, I have declared an array, named it as myvar, and it is of type integer. It is three-dimensional array. So total number of variables that this array can store is 1 multiplied by 2 multiplied by 3, which will be 6. In this another example, I have declared an integer array with dimension as 2 and 3. So total data size will be 2 multiplied by 3, that is 6. The better way to visualize two-dimensional array is like this. In this table, these are your rows and these are your columns. So in array declaration, 2 is your row and 3 is your column. So array of 2 and 3 is basically 2 rows and 3 columns. If you declare an array of, let's say, int foo 5 and 3, then we are declaring 5 rows and 3 columns. So these are 5 rows and these are 3 columns. Each element is indexed like this. So 0th row and 0th column, 0th row, first column, 0th row, second column, first row, 0th column, first row, first column, first row, second column. Similarly, in this case, it would be 0, 0, 0, 1, 0, 2. Then next row is 1, 0, 1, 1, 1, 2. Then 2, 0, 2, 1, 2, 2, 3, 0, 3, 1, 3, 2. And finally 4, 0, 4, 1, 4, 2. Important point to recollect here is that always index starts from 0. Let us take one more example. In example 2, we are declaring a character array. It's a two-dimensional array. For simpler understanding, we are initializing the variables like this. So this is my first row and this is the second row. Also notice in this case, I have not specified any size. So this is an unsized array. However, the second parameter is compulsory. So you need to at least specify data size of your second size. Now, why this is optional? Because as we have initialized the array, so total data size is 10. Just by counting, you can identify that. So total elements that we have specified over is 10. So 10 divided by 5, you get 2. So the compiler will automatically understand that this array is of size 2 and 5. Now let us take this third example. When you specify both the size elements, this is called a sized array. In this example, I have initialized this array by specifying values. So again, these are my rows and these individual elements are my columns. You can also initialize arrays like this. Compiler will not throw an error, but it will obviously give you a warning. However, it is always better to initialize your array elements like this. So for you, visualizing values becomes easy. Now let us finally look into how we can access values that are stored into arrays. So here I'm just printing an integer and I'm specifying the value location. So when I say 2, 1, so 2, 1 is this part. So whatever the value which is stored at this array location will be displayed over here. Similarly, if you want to store value at a certain array location, then you can use scanf statement as regular and then specify address, variable name and the location where you want to store those values. So in this case 32, the value entered by user will be stored at this location 32. Similarly, you can assign values like this. So whatever the value that at the location of array 2, 3 will be stored into variable B. So this was all about multidimensional arrays. In the next lecture, we'll check few programs on multidimensional arrays. In this lecture, we are going to talk about passing arrays to a function. Very important point to remember over here is that whenever we pass arrays to a function, those are always passed by reference and not as values. Now, because arrays are collections of similar data types, we can either pass individual array elements or we can pass entire array. So let us first see how individual elements can be passed. So for passing individual elements, we will require pointers. So to your functions, you can pass pointers and use them as a formal parameter. That is, you can directly use these pointers inside of functions. So here is an example for this. I have defined a function name as foo and I am declaring an integer pointer, and after that I am just displaying that value. So inside of main, I have declared an array of size 4, initializing it to 0, 1, 2, 3, and then I'm calling my foo function. Here, notice that I am just passing address of array element 2, that is second position. So 0, 1, 2, address location of this array element will be passed. So what is happening over here, once the call is made, star param, which is my integer pointer, will be pointing to this location. So indirectly it is something like this: star param equal to address of array 2. Okay, so we can read it as value at address location of array 2, which is 2. So here the output will be 2. So this is how we can pass single array elements to a function. Now let us check how we can pass the entire array. In the previous lectures we have seen that you can declare arrays either sized or unsized. So similarly, inside of your function you can have a sized array or you can have an unsized array as well. So let us take one example for it. I have declared an function to which I am passing an unsized array, and then with the help of a loop I'm just printing all the values which are present over here. Inside of main I have declared an array element of size 4, initializing it to 0, 1, 2, 3. Then I'm just displaying a statement values before function call. Then I'm calling my function foo, which I have defined over here, and then I'm just passing name of my array. Notice that though I have not written ampersand mark over here, still the array is being passed as reference only. No two different copies are created for the same array. And then I'm just providing new line character so that I have few space in my output screen, and I'm just printing values after function call, and then with the help of a for loop I'm just printing local variable which is array. Okay, so notice what is happening in the function. I'm displaying value of the local variable which is param over here, which will be holding reference to array, but at the same time once the printing is done I'm also incrementing the value. So 0th location will be displayed first and then value will be incremented. Similarly, in the next iteration, second value will be displayed and incremented. So in our case, 0 will be displayed first and then it will be incremented to 1. Similarly, 1 will be incremented to 2 and so on. So our final output is values before function call. Because this is function call, so these statements are getting executed. So we are just displaying current values, and at the same time the values are getting incremented, and then when controller come back to the main function where we are displaying values of array which have got changed now, so compiler will print 1, 2, 3, 4. So this is a very important example which shows us that arrays are always passed by reference. We have also seen how we can pass an complete array with the help of an unsized or sized arrays. In this next module, we are going to start our learning on strings. It is a character array. So let's initialize a string. We can have character as data type and then your variable name. You can alternatively declare an initialized string like this also, where you are not defining the size and instead you are directly writing your complete string inside of double quotes. So total array size in this case is these 7 characters plus /0 character at the end. So total 8. Alternatively, you can also have a character pointer char star my string is equal to your string. So this is nothing but a character pointer to your string using this character pointer. Let us now check how a string is stored. As discussed earlier, string is nothing but a collection of characters. So all character locations will have an index, and every character index will have a value, and each index and each character in the set will have separate address. So this is the first character element having this as address and this is its value, and followed by it are subsequent characters in the string, and this is important character which denotes end of the string. This is also called as terminator point for the string, so that compiler understand that it has to print from this point till this point. So this point will not be printed at all, but it is important for compiler to understand that this is the end point of the string. You can print a string directly like this using %s as format specifier and then pass your string variable. You can also loop through your string using a normal for loop starting from I and till /n is reached, and that can be done using your character array, then passing index and checking it with whether it holds /0 or not. So while looping, if you check this as a case, so my string 0 is k, so k will be printed, I will be incremented, condition will be checked. Now my string 1 will be checked whether it holds /0. So it does not, so O will be printed, and so on. These letters will be printed. So when I becomes 6, that time this final letter D will be printed, and when I becomes 7, so my string 7 is this value, so this condition becomes false and loop will be terminated. So that is how, using normal loops, we have printed the string. This knowledge is required when we will be doing some string manipulation programs wherein we are required to copy a string from another or convert string into uppercase or lowercase. There are standard functions ready-made available in C, but there could be chances where you will require some slight modified version of this function. So in those cases, you will require to write your own function. So it is best that we understand how string manipulation can be done. So that is something that we'll be checking in the upcoming lectures, but we will be also checking few predefined functions which are available in C. Before we jump right into writing programs, let us revise or discuss again ASCII characters. So capital A as character has equivalent integer value as 65, B has equivalent integer value as 66, and so on. So capital Z is 91. Also small a is 97 and small z is 122. Digit 0 as character symbol is integer value 48, and so on. Digit 9 as 57 as integer value. So you can have basic ASCII characters starting from 0 till 255, which are total 256 characters, and these are part of these 256 characters. Apart from these, there are special characters like this, or a complete stroke, or a dotted vertical bar, which we have seen in earlier lectures. But we are revising it again because we will be requiring this knowledge in upcoming programs. As discussed in previous lecture, in C language there are a few inbuilt string functions available to us which we can directly use for string manipulation. So let us check few inbuilt functions which are available to us. First one is strcpy, in which s2, the value of second parameter, is copied into first parameter. Next is strcat, it concatenates string s2 onto the end of string s1. So in other words, operation is performed like this: s1 is equal to s1 plus s2. So all the contents which are in s2 are added at the end of s1. So if s1 is equal to abc and s2 is equal to xyz, after using strcat functions on these two strings, our final output would be s1 as abc xyz. Then the next function strlen gives you length of s1. So if s1 is equal to abc xyz and s1 is passed to strlen, in that case output would be 6. Then the next function is strcmp. It basically compares two strings s1 and s2. So the function returns 0 if s1 and s2 are equal or they are the same strings. It gives you output less than 0 if s1 is less than s2, and it gives you output greater than 0 if s2 is greater than s1. But let me explain you how function is executed internally. Suppose we have two strings a, b, c, d and x, y, z. So what compiler does is it starts subtracting characters ASCII value from first string with ASCII value of second string. If results are non-zero, then difference is written by the function. So whatever the ASCII value of a minus ASCII value of x, that will be the result. If your string is a, b, c, d, a, b, c, in that case the result is 0, here is 0, here is 0, but here it will be ASCII value of d minus 0 because there is no character available here. So in that case the answer would be in positive. So we can guess that s1 is the greater string. We will require this knowledge when we are required to compare two strings without using strcmp as an inbuilt function. Apart from these, there are three more functions that we can discuss. One is strlwr, which converts given string into lowercase. Then strupr, it converts given string into uppercase. Structure is a collection of variables of different data types. As compared to array, which are collection of similar data types, structure is collection of variables of different data types. So inside of a structure, you can have collection of variables of data type int, float, character, and so on. Now let us check how we can define a structure. So struct is a standard keyword in C which is used to define your structure. So after struct, you can write your structure name, and then inside of curly braces you can have collection of your variables which can have any data type. Notice a semicolon at the end of this structure definition, which is compulsory to have. Now let us check how we can declare a structure variable. To declare a structure variable, we again use keyword struct and then structure name, and after that you write your variable name. So variable name is a variable of type structure name. There is one more method using which you can declare your structure variable. That is, you can immediately write your variable name after structure definition. So that is between curly brace and the semicolon. Now let us check how we can access data members of a structure. So this is your variable of type structure, and we use a dot operator, and after that we write member name. So if I have a structure student and inside it there is a variable as role, then if we declare a variable of type student, which is the structure, then we can access a role using this syntax, that is std1.role. Now let us check how we can initialize the structure variable. So there are two ways to do it. Immediately after your structure definition, you can specify your variable name, and using equal to operator you can initialize value of that structure variable. So inside of structure student I have a character array, then an integer and a float variable. So I'm initializing it with a string, an integer, and then finally a float variable. So this corresponding value will go inside of std1.name equal to Prashant, then std.role equal to 10, and then finally std1.marks equal to 77.99. There is one more method using which you can initialize your variable. So when you have your structure defined, you can simply write struct structure name and your variable name for that structure, and then you can specify values for your structure. In this lecture we are going to learn about array of a structure. Assuming this to be my structure definition, so structure underscore name is a structure that I have defined over here. So for declaring an array of this structure, we will just write struct structure name, your variable name, and inside of square bracket we'll write size. So here we are declaring array of size 10 of structure variable structure underscore name. There is one more method using which you can declare array of structure, that is simply by writing your variable name and size over here. In this lecture we are going to learn about structure within structure. So what we are going to basically do is we are going to use a structure inside of structure. So if we assume structure 1 and structure 2 as your two structures, then inside of structure 2 I'm declaring a variable struct1 of type structure 1. So structure 2 is having some data member inside of it, out of which there is one data member of type struct1. So inside of struct1 there would be data members of struct1. So when we declare a variable struct2 of type structure 2, we can access variables of struct2 as struct2 dot member name. Similarly, we can access data members of variable struct1 of structure 1 as struct1 dot member name. So similarly for struct2, which is variable of type structure 2, which is variable of type structure 2, after that we can write dot struct1, which is declared over here, and we can use another dot operator to access data members of struct1. So this is one example of structure within structure. So we are using struct1 inside of struct2. In this lecture we are going to learn about file operations in C. Why do we need to use files? When we use files, we can store data which can be re-accessed. That is, when you write data to a file, you can re-access that file later on. Writing data into files is more efficient way of organizing your data. Another advantage of using files is that your files can be shared with other programs and other computers. For example, when you create a file in C, that file can be opened in any text editor. So that is how we can re-access the data, and it can be shared with other programs and computers. These are main important advantages of using files. In C language, we can perform these all operations over the files. You can create a fresh new file, you can open an existing file, you can read an existing file, you can write contents to a file, you can seek a particular section in the file by traversing to it, and you can close a file which is already open. Now let us try to visualize the file system, assuming these squares are nothing but memory locations. So this could be a starting point of my file, and these are data written into those files. All files have a special pointer at the end, that is EOF, that is end of file. It is the special pointer using which we can identify that file has ended over here. To read a file, we create a file pointer which points to this location. Suppose I'm using a file pointer as file star FP, then suppose if it is pointing to this location, then using this pointer we can traverse across all other memory locations operation of the file. We can read contents, we can write content using this file pointer and some readily available functions in C language. Now let us check what are different file modes which we can use to perform file operations in C language. So R is file mode for reading data from a file. W is writing to a file, and in this case contents are overwritten. So if your file that you have opened in write mode has some previous content, then that whole content will be erased and new content will be written over it. Then there is A mode, that is append mode. It adds content after the end of your file. So suppose your file was having data as ABC and you are going to write XYZ to it. So ABC will be written as it is and XYZ will be added to it. Then there are more few advanced file mode, that is R+. Using this mode, you can read existing content, you can write new content to the file, and you can modify existing content as well. Similarly, we have W+. In this case, contents are overwritten like the case of W. In addition to it, you can write new content, you can read back new content that you have written, and you can modify existing content from the file. Then finally, there is another mode as A+, in which you can read existing content, you can append new content at end of the file, but in case of A+, you cannot modify existing content. So these are 6 different file modes which are available to us in C language. So you can use this mode depending on your coding requirements. Additional important points to remember are mode A, W+, and A+ creates a new file if specified file does not exist. So there won't be any prompt as such. Those files will be created by the compiler. In the next lectures, we are going to check few programs on file operations so you understand this concept better, and there are few readily available functions which we are going to use. So the functions and keywords that we are going to use are fopen. It's a function which opens a specified file in the specified mode. Fclose is a function which closes the specified file. GetC reads character from the current cursor location. When you open a file, cursor will be at the first location initially at this location. When you use this function getC, so data from this location will be given to you and cursor will move on to the next location. Similarly, when you again use getC, then this data will be given to you and cursor will move on to the next location. Then we have putC as a function. So it will write and data to the current cursor position. Once the data is written, cursor will move on to the next location. FgetS reads line from the file. So your file usually have multiple lines into it. So it will read line by line. Similarly, putS is a function which writes line completely, unlike putC which writes character by character. Then we have a special keyword EOF which specifies end of the file. So when we are going to read these contents, if function returns me EOF, then we can assume that cursor has reached end of the file. In the next lecture, we'll check few programs on file operations, so that will make your understanding more clear. In the next lecture, we are going to talk about command line arguments. So what is a command line argument? To any command, when we pass additional parameters for execution of this command, then these are called as command line arguments. So when your program gets compiled, it will create a machine level code file that would be an exe file. So if your program is going to consume command line arguments, then from the DOS prompt, so at the time of execution from DOS prompt, you can specify your exe name and you can pass your parameters like this. Few examples of command line arguments are copy command and mkdir command. So while using copy command, I am writing two parameters abctxt and pqrtxt. So these are nothing but my command line arguments. Similarly, in case of mkdir, we are passing directory name which will be created. So directory name is a command line argument. So in order to consume command line arguments inside of your main function, we can use these two parameters. First is argc, which is nothing but number of arguments that will be provided to this main function. So it could be 2, 3 and so on. We require argc as a variable so we can perform operations on parameters that will be sent. So all the parameters that are sent will be stored into this array of character pointer. So this will have your multiple arguments. So argc can be used to validate whether user has entered correct number of arguments, and then on these arguments you can perform your operation inside of your main function. Using command line arguments is a very important topic. In the next lecture, we are going to write a program where we will supply command line arguments to our main function and perform some operations based on the inputs. In one of the previous lectures, we have seen data types. In this lecture, we are going to see more data types. In C, there are two types of data types. One is basic data types, in which we have int, float, and char, which we have used in many programs. And the second type is derived data types, that is user defined data types, in which we have used arrays, structures, pointers already in some of the programs. We have not yet seen enums, and we are going to learn about it in one of the upcoming lecture. But in this lecture, let us check what are the data types which are available in C. So we are going to refer this table. In the first column, we have data type, then we have range available to that data type, and we have bytes that will be consumed by variable of that data type, and finally format specifier, which we can use to print variable of that data type. So first one is signed char. When you say a signed, it can be positive or negative. So it utilizes 1 byte. So 1 byte is equal to 8 bits. Hence in the memory it will consume 8 bits. So out of that, when it utilizes 8 bit, so total combination which are available is 2 raised to 8, that is 256. But in that, in order to store negative numbers, there has to be some mechanism using which we can identify whether the number is negative or positive. So compilers use different methods for this. First one is signed magnitude, second method is 1's complement, and third method is 2's complement. We are not going to go into much of the detail because that is really not required in the scope. But for the simplification, I'm going to explain what is signed magnitude. So in case of signed magnitude, first bit is used for storing sign of the number. So we can store either 0 or 1. So 0 is used to represent plus sign, and 1 is used to represent minus sign. So rest of the 7 bits are used to store data. So we have 2 raised to 7 possible combination, that is 128. So range starts from minus 128 and it goes till plus 127, because the range starts like this: minus 128, minus 127, and so on till minus 2, minus 1, and then comes a 0, and then 1, 2, 3 till 127. So because of this 0, the final range that we can achieve is 127 and not 128. So this was the case with signed character. We use %c to print a signed character as format specifier. Then we have unsigned character, in which this sign bit is also used as data bit. So we consume complete 256 valid data combinations. So our range starts from 0 and it goes till 255. To print variable of unsigned char, we use %c. Then we have short signed int. It is almost similar to integer because it uses 2 bytes. So we have 2 raised to 16, that is 8 plus 8 different combinations. So 2 raised to 16 is 65536. Hence if we divide it by 2, we get the starting number as minus 32768 till 32767. Then we have short unsigned int, where the first number would be 0 and the final number would be 65535. We use %d and %i to print short signed int and %u to print short unsigned int. Signed is almost similar. Signed int also has 2 bytes of information. It has the same range as short signed int, and we use %d again to print signed integer. Unsigned is again the same ranges, and %u to print unsigned int. Because the highest number that we can store is 65,000. So what if we need higher ranges? So in that case, we can use long signed int, which uses 4 bytes and has higher range. Similarly, we have long unsigned int, which has double the range, but it will show only positive numbers. To print long signed int, we use %ld. So L is for long and D is for decimal. And to store long unsigned int, we use %l, that is L for long and U for unsigned. Then we have float, which we have already used, which has this range and total number of bytes is 4. We use %f to print a float. Then we have double, which has higher range than float as it uses 8 bytes, and we use %lf to print a double. Then there could be cases where you'll still require higher range, so you can use long double, which has this much of range, which is a huge range, and it uses 10 bytes to store values, and its format is %LF. The table that we have used here is basically considering 60-bit compiler. So there could be chances if the compiler is of 8-bit or 32-bit, then these ranges would vary. So all the sizes and ranges are compiler dependent. Apart from this table, there are these format specifier that we can use in addition. %e and E is used to print float or double in exponential format. Then %d and %g is used to print float or double, and we can use %f or %e as required in the program. Then %o is used to print unsigned octal value. %p is used to print pointer address stored in a pointer. So when a pointer is pointing to another variable, we can print that address location using %p. Then %s is used to access array of character that we have used in many other programs related to strings, and %u, which can be used to print unsigned decimal. And finally, we have $X, which can be used to print unsigned hexadecimal value. So an example for hexadecimal value is suppose D and h. So if your variable is having value as d and h, then %small x will print this, but %capital X will print value as dh. So that is all we have for data types. You are always required to choose your data types carefully, because if you are going to use very small values, there is no point of declaring a variable of long double. So assuming if you are just going to store x is equal to 10, there is no point of declaring a variable of type long signed int. So we need to be very careful while using data types. In this lecture, we are going to learn about more escape sequences. We have used few of the escape sequences previously, like /n, which takes cursor to the next line, and /t, which is for tab. So it acts like a tab on your keyboard. Then we have something as // which is backslash character. So it will print a single backslash. Then we have /quote, it will print a single quote. Then we have /double quote, which will print double quote. Apart from this, then we'll check now other escape sequences. So /a, if it is used inside of a printf statement, then as soon as the printf statement is executed, it will play a beep sound if your motherboard has a device to play a sound. So this is very important escape sequences. So in case of you're trying to deny an access to user, or if you're printing some very critical message and you want to capture user's attention, in that case you can use /a. The next is /b, which is a backspace. So suppose you have printf statement and you have printed India, then the cursor position will be here. And if we have specified in printf statement something like this, printf India, then /b. So this /b will take cursor position to one space previous. So it will take it here. If you have two /b, then it will come to this place. And suppose if after this single /b you have maybe 1 over here, then this a will get overwritten. So instead of a, 1 will come over here and cursor will move on to next location. So we have seen backspace. Now next is form feed. Suppose you have printed few lines over here, and after that you are required to skip this space and start printing from the next page first location. In that case, you can specify /f. You won't find any significant changes on your console output screen, but when you're going to use a printer as output device, in that case form feed is a very useful escape sequence. So if you have used Microsoft Word, so form feed is nothing but like a page break. Then the next is carriage written, that is /r. So suppose cursor is at this location, it has printed a few characters and it is on the final location somewhere here. So if at this location /r occurs, then this cursor position will go again back to the first location in the same line. And if there is anything further, then it will get overwritten by it. So for example, if you have something like this, print f inside of double quote a b c d, then you have suppose /r x y z, then on the output screen a b c d will be printed, cursor will be at this location, and because of this /r it will move back to the starting position, and then it will start printing x y z, and then cursor will be at this location. So your final output would be x y z and cursor will be below the d. Then we have question mark. So if you want to print a question mark, then you can use /question mark. All octal numbers can be printed using /n, and after that you can have your octal number. Then you can use / and after that few numbers which can be represented as a octal number. Similarly, you can have /x and then numbers which can represent an hexadecimal number. We have already used /0 couple of times in previous programs, where /0 is used to represent a null pointer. In this lecture, we are going to learn about typecasting in C. It is used to convert a variable from one data type to another data type. So there are two types of typecasting. One is implicit conversion, another one is explicit conversion. In implicit conversion, typecasting happens automatically. So let me explain this by using one example. We have int x equal to 10 and character y equal to inside of single quote a, which is nothing but 97, and I'm writing instruction as x is equal to x plus y. So here this y will be converted to an integer implicitly by the compiler. So 10 plus 97, so the output would be 107 for this statement, and in the next statement I have float x is equal to x plus 1.0. Now we have x updated to 107 because of this statement, which is an integer value, but here because we are adding 107 with a float value which is 1.0, so compiler will produce an output of 108.000 and it will be stored into float z. So in the next lines I'm I'm just printing those values of x and z. So final output is here. In this program, we have seen how compiler implicitly converts data type of used variables. However, we can do this explicitly, and syntax for typecasting explicitly is if we can specify your data type inside of parenthesis, and after that you can have your expression. So here is an example. I have double x is equal to 1.2 and then integer sum is equal to integer x plus 1. Now note that x is of type double. However, I am asking compiler to treat it as integer over here. So 1.2 as an integer is 1. So here compiler will do 1 plus 1 and the final output would be 2. So in the next line we are printing sum, which has been updated as an integer value 2, and it will just simply print sum equal to 2 as output. Typecasting is important where you do not want to use multiple variables just to achieve a certain result. Instead of that, we can just typecast existing variables to achieve our result easily. Typecasting is widely used between combinations of integer to float, float to integer, integer to character, character to integer, and so on. In this lecture we are going to learn about enumerations, which are user defined data types, and these are mainly used to assign names to integral constants which are used in your programs. Most important benefit of using enumeration is that it makes your program easy to read and maintain. Let us try to understand this by a program so that we'll also know how to use enumerations. So enumerations can be defined using keyword enum. After that you have enum variable. So inside of year I am specifying complete list of months which are available in a year. So this is my whole list, and then inside of my main program I'm writing a loop. It is starting as I equal to Jan, I less than December, I plus plus, and we are just going to print value of I. So internally what is happening, starting from Jan till December we have total 12 values. So for 12 times value of I starting from 0 will be printed till 11. So how this happens is when we define an enum, starting value is considered as 0, then 1, and so on. Hence here Jan is 0 and December is 11. So technically your loop was I equal to 0, I less than equal to 11, I plus plus. That is why it has printed output as 0, 1, 2, 3 till 11. Few important points to remember in case of enum is that two enums can have the same values. So if we have enum as day, then Sunday is equal to 1 and Tuesday can also be equal to 1. In case of enums, we can initialize values like this using equal to operator. In case you do not specify any values, then the value of that particular name is as its previous value plus 1. So in this case, for Monday we have not specified any value, but previous element is initialized to 1, hence Monday will be treated as 2. Similarly, for Friday we have not specified any value, but because we have specified 10 as value to name Thursday, hence Friday will become 11 and Saturday will be 12. So it is not compulsory to have values for all the names. We have already seen that when we have not assigned any explicit values to all the names, then the starting value will be 0. Like in this program, Jan was having initial value as 0. Now the next point is all enum constants must be unique in their scope. So for example, suppose if I have these two enums and if I am using this enum constant as failed and failed in these two results, in this case compiler will give an error. So across your enum, all the enum constants should be unique. So this is how we use enumerations in C. These are very easy to use. So few common examples where you can use enum is to declare weeks, month, or state of a particular process. So these are few examples of enumerations. In this lecture, we are going to learn about bitwise operators. There are total 6 different types of bitwise operator. First is AND operator, which is denoted by a single ampersand, then an OR operator, which is denoted by single vertical stroke, then XOR operator, then we have left shift operator, then right shift operator, and ones complement, and these are symbols for these operators respectively. Now let us see how bitwise operations are performed using these operators. So in the first table we are going to check bit results for AND, OR, XOR, negation, and then ones complement. So if we have two bits as X and Y, then these are all the possible values of X and Y, and when we perform AND operator on X and Y, so in case of 0 and 0 we get 0, in case of 0 and 1 we get 0, and in case of 1 0 we get 0. Only if both X and Y are 1, then we get 1 as a result of AND operator. And in case of OR operator, when both the results are 0, we get a 0, else we get 1. And in case of XOR operator, if both the results are same like 0 0 1 1, then we get 0, else we get 1. And in case of 1's complement, the number is converted into opposite. That is, if we have 0 as the bit value, then it will be converted to 1. Similarly, if we have 1 as bit value, then it will be converted to 0. Let us take few examples. So if x is 10, then its corresponding binary value is 1010. So this first location is denoted by 1, second as 2, third as 4, and fourth as 8. So we have 1 over first and third position, so 8 plus 2 is equal to 10. That is how binary numbers are denoted. And we are going to assume y as 14. So this is binary equivalent of decimal value 14. So if we perform AND operation over these 2 bit values, we know that when we have both the bits as 1, only in that case we get result as 1. So here both the numbers are 0, so we get a 0 over here. Here we have 1 and 1, so we get 1, and then we have 0 and 1, so we get a 0. Similarly, in the final column we have 1 and 1, so we get 1. So the result that we have obtained is 1010. So the equivalent value is 10. So when we apply bitwise AND operator on 10 and 14, the result would be 10. Now let us check the same with OR operator. In case of OR, we know that when both the bits are 0, we get 0. So only in this case both the numbers are 0, hence we have a 0 over here, and in the rest of the columns we have 1 somewhere, so we are getting 1 in all rest of the cases. So our result is 1110, which is equivalent to decimal value 14. Finally, in case of X and OR, we are going to write 0 when both the values are same. So here we have 0 over here. Similarly, we have 2 zeros over here, so this will be 0. Similarly, in the third column we have 1 1, hence a 0. Only in the second column we have 0 and 1, so we are going to write 1. So when we apply binary XOR on 10 and 14, we get 4 as the output. Then we are going to check left shift and right shift operator. Assuming value of x to be 1110, when we apply right shift by 1, then all the bits from second position will be shifted to the right. So 1 will go here, this element will go here, this bit will go here, and this bit will go here. So our final output would be 1 1 1, and the remaining bit will be replaced with 0. Similarly, if on the same x we are going to perform right shift by 2, then these two elements will be skipped. So these two ones will be shifted to this place, and on the remaining spaces we'll add 0 0. Exact opposite happens in case of left shift operator. So assuming 00 11 as my value of x, then if I'm going to left shift by 1, then these last 3 digits will be shifted to left hand side, forming this 0 1 1, and we will add 0 on the last space. Similarly, when we have x less than 2, that is we are applying left shift operator by 2, so these 2 bits will be shifted to the left hand side, those will appear here, and the remaining bits will be replaced with 0 0. So that is how left and right shift operator works. Now we are going to check final table, that is for 1's complement, assuming value of x to be 1010, which is equal to decimal value 10, and then assuming value of y as 1110, which is equivalent to decimal value 14. And when we apply 1's complement to x, so all the bits will be inverted. So instead of 1 we are writing 0, instead of 0 we are writing 1. Similarly, for this 0 we are writing 1, and for this 1 we are writing 0. So equivalent of this is decimal value 5. Similarly, for 1's complement of y, for 1110 we will write 0001, that is equivalent to decimal number 1. Let us take one example to understand this in more detail. I am using an unsigned character a initialized with 5 and b equal to 9. So this is 8-bit representation of 5, and this is 8-bit representation of 9. When we apply AND operation over a and b, then if you just compare bit by bit, then this will be your output, because this final bit is the only position where we have 1 in both the variables at the same bit level. In rest of the cases, everything will be 0. Similarly, for OR operator, if we just take these first 4 bits in both the variables, both are 0 0 0, so we are writing 0000 over here, and for the next bits it is 0101 and it is 1001 for b. So when we apply OR operator, we will have 1011, so which is your second part. Similarly, in case of OR operator, when both the digits are same, we write 0. So first 4 bits are 0, hence we have written 0 0 0 over here, and for the remaining bits we are going to write 0101 1001, so these will will be 0, this will be 1, this will be 1, and this will be 0, which is your remaining 4 bits. 1's complement over A is very simple. It is just inverse of this variable. So first 5 bits are inverted to ones, as first 5 bits are 0 over here, and for next 1 0 1, which are next 3 bits, we will write 0 1 0. Next we are going to apply left shift operator on B. So all the values starting from this location till this will be shifted by 1 digit place. So we will have result as 0 0 0, then 1 0 0 1, and then the final digit will be added as 0. So if you check this line, your result is this. Similarly, when we again apply right shift operator on B, then the output would be this. That is, only this last one will be excluded. Everything else will be shifted to form this part, and then this 0 will be added in addition. So this was all about bitwise operators. It will be great if you can practice these programs by yourself, because that is the only way using which your concepts will get more clearer. In this lecture, we are going to learn about unions. Unions allow you to store different data types in same memory location, and in case of unions, memory size equal to the size of largest number. For example, if you have a union where you have 3 character array, let's say of size 3, size 4, and size 2. So character array of 4 is the largest among this. So this union can have maximum size as 4 bytes, because a character utilizes 1 byte to store, and we have 4 characters, hence 4 bytes will be utilized by this union. Also in union, when you store value at particular location, then previous value which existed in other variables will become meaningless, or it will get converted into some garbage value which we may not use. Similarly, when we assign value to some other number, then that value can be meaningful, but other values will turn into some garbage value. So let us see what is syntax for union. So union is a keyword that is used, and after that you specify your union name, and then inside of parenthesis you have your members of the union. Here is one example of the union. Here my variable name is my union, and inside of this union we have 3 members. So we know that integer takes 2 bytes, float takes 4 bytes, and because this is a character array of size 20, it will take 20 memory locations. So 20 being the largest data member, so size of your union will be 20. Similar to structure, you can declare your variable of union like this, that is just before your semicolon, or alternatively, you can declare your variables like this. You'll need to write keyword union, after that name of your union, and then your variable name. Suppose I declare a union variable as union underscore var, then we can access union members like this, union underscore var dot I equal to 10, which is similar to accessing struct members. Now suppose this to be 2 consecutive statements in your program, then once you write this statement, the value will be stored into same memory location, but as soon as you write this statement, so value of I will become something else. So this is a slight disadvantage of using union, that it can change other values indirectly, but there is an advantage also, that when we use struct, and if the struct has large number of members, and if you are going to use very significant amount of members at a given instance, in that case large number of memory location will be completely unutilized. So comparing to that, union can be very less expensive operations in terms of saving memory.